Good morning, good afternoon, everybody. This is your Friday HSM Hangout. Thank you so much for joining us today. For those of you that are just joining us for the first time, I'd like to make everybody aware that every Friday, same place, same time, we have an HSM Hangout where an Autodesk application engineer is available showing us new technology within our platform and answering questions live. So please tune in, tell a friend. My name is Jordan Roberts. Today we have Wayne Griffenberg, Autodesk application engineer. Wayne, what do we have in store today for everybody?
So today we're going to look into applying some of those 3D Toolpath strategies to a part to rough it and finish it, applying some of those containment for Toolpaths that we looked at last week, or last time.
That's great. Yeah, just an extension of what we covered last week. So before we get started, just a quick couple of polls here. We always like to understand the equipment everybody's running. So get your votes in, answer the poll quickly. We'll move through these rapidly. Great. Thanks for voting, everybody. Appreciate that. And Wayne, any thoughts? Look at this. The majority is running Haas today. That's great. We do have a large amount of others, so feel free in the chat window to chime in with the brands that you're using, who you are. If you have any Instagram handles, feel free to share those. We love interacting with our customer base on Instagram as well. So please share your business, and we'll also repost some of your stuff as well if it's applicable. So we want to understand how long everybody's been using the HSM product line. Are you brand new? Have you been using it for a while? We do have a free product that plugs into Inventor and SolidWorks, which is an incredible product. So highly encourage everybody to take advantage of that application. It's called HSM Express. Great. Thanks for voting, everyone. Appreciate it. And look at that. So good distribution today, Wayne. We've got about 6% brand new. 50% have been using it for a few months. And then look at that. Just about 44% right there are existing repeat customers who have been using this stuff for a long time. Thanks so much for coming back week over week, guys. We really appreciate that.
You guys rock.
Yeah, and seeing that is really what makes us able to get the budgets to put these things together. So really quickly, what CAM software are you guys currently using? I have a feeling that we're going to see a lot of people on the HSM platform, but get your votes in. Let us know. Okay, let's take a look. And wow, look at that, Wayne. So 82% of our audience today is using the HSM platform, which is great. We love to see that. Okay, so real quickly, we're going to run through a couple of things here with everybody, and I've got some of these military logos up there because we've recently been having a great deal of success with some of these entities. I'd like to just go through a couple of quick things. First of all, if anyone's ever going to be in San Francisco, or Boston for that matter, please let us know. So if you have a contact with a reseller or with somebody that works directly with Autodesk, and you happen to be making a trip to San Francisco or Boston, let us know, and we'll get you scheduled for a tour of our facilities. The one in San Francisco is called Pier 9. It's an amazing facility. If you get the opportunity to visit it, please do so, and let us know. We do have to schedule those visits, but it's well worth your time. It's right on the water, and it happens to be right next to the Autodesk Gallery, which is consistently ranked one of the top free things to do in San Francisco, and that's open during the week. So if you're ever interested in what Autodesk is up to outside of HSM, the Autodesk Gallery is a great place if you happen to be in San Francisco to take advantage of some of the innovation that's happening at the company. It's just absolutely tremendous. I wanted to share this with everybody today because I think it's important to note, and it might be a little bit hard to see, but if you look, what we're looking at is a distribution of the commercial seats shipped from 2012 through 2015. And what you can see here is that Autodesk has rapidly become, and if you look down here, we also have Delcam. Wayne, I should probably combine that data and seeing as we own the Delcam product line now, but what you can see is over the last few years, Autodesk has become a major player in the CAD/CAM space with the most seats shipped of software out of any other CAM company on the planet, which is absolutely a tremendous feat to have that happen in just a short amount of time. But what's also even more tremendous is the Autodesk Education Program, which we'll cover at the end. So for those of you that know students or educators, Autodesk has an amazing product, amazing program rather, and what you can see here is this is what the students are learning because it's just a beautiful, intuitive workflow and user interface. For most of you, since we have an audience today that understands the value of integrated CAD/CAM and has been using it a long time, that's awesome. But for those of you that might not be familiar with why we use integrated CAD/CAM in our machine shops, this graphic right here sums it up perfectly. Because all we really need to do is have our data, define our job setups and our operations, generate toolpaths, and verify that toolpath to post our code. So what we can do is, we can streamline all of that and just have a very, very efficient workflow as we're going through our process. Here we have a couple of customer success stories which are truly amazing. The feedback that we get from our customers every week is absolutely outstanding. So if you have some tremendous success and you want to leverage the social currency of Autodesk social media channels and get your shop out there into the stream of consciousness that is the HSM community, please send us those customer success stories. We love to share those successes. You can see that some of these numbers are absolutely staggering, a 38% reduction in programming time, and the numbers off the charts for our friends over at the depot in Albany, Georgia. Just really quickly want to touch on the benefits of any CAD. For those of you that don't know, that are using Inventor, and for those of you that are on the SolidWorks platform as well, the AnyCAD program is available through Inventor HSM, and it's absolutely a game changer for the job shop because what this allows us to do is be more flexible with the jobs that we take in and the work that we take in. We can mitigate against risk if we're more flexible and more agile, but what AnyCAD does is it allows us to take all these different kinds of file types and pull it into Inventor, and we can just put our toolpaths right on the part so fast that it's really, really driving a lot of profitability within the machine shop. And so really quickly, I won't spend much time here, but just so you guys get a visual, this is the workflow. You get your CAD data, you find your job setup, your operations, and then right there, you're just, you can simulate your toolpaths and post your code. It is that simple. We have 3 flavors of it. So as you guys know, there's the free version. This is so if you've got a 2.5D operation, now I'm going to recommend that if 90% of your workload is 2.5D, that get started on Express, but definitely take a look at 3D toolpaths for 2D parts. You're going to improve your profitability tremendously by using those strategies. We have this 3-axis package, which is by far the most popular in industry, 80% of the market, and then we have a 5-axis package, and we have a new product called Fusion, which is a cloud-based product, and we have a new product coming out called Fusion Ultimate, which is going to have those 5-axis toolpaths inside of it as well. So the HSM platform, Inventor, SolidWorks, and the cloud, you have your option. It's absolutely tremendous, and the workflows are relatively all the same. If anyone ever has an issue or needs to get in touch with somebody at Autodesk and they just don't know where to go, feel free to leverage my desk. I'm always here to help. My name is Jordan Roberts. That's my email. Please reach out to us on Twitter, Facebook. We have a Snapchat. We love seeing what our customers are doing. We love sharing those successes. So Wayne, that's really all I have today. I want to get into the software and see what you have to show.
Awesome. Sounds good. Thanks, Jordan. Let me just show my screen here. Alrighty. So last time we talked about our 3D containment. We talked about the Toolpaths and HSM. This is Inventor HSM. This is the video from our last webinar. We talked about how to contain the Toolpaths within a specific geometry of that part or an area that you're trying to machine. This week we're going to jump into a part that looks like this, and we're going to walk through some of those Toolpaths on how to set them up and contain them to cut out a part that looks like this. So in those previous webinars, if you take a look and do a search through our YouTube channel, you'll see that we have a lot of webinars that talk about how to set up your tool libraries and how to set up your part to be able to get ready to machine. So I already preset some of these tools in here that we're going to use to work with. So I want to use an adaptive clearing to get started. So I'm going to go up to adaptive. Really good roughing strategy. Keeps the tool engaged with the material as much as possible. We're able to take those deep cuts and it comes back with successive shallow cuts to get closer to the part. So I'm going to choose adaptive. I'm going to clear out here. So I'm going to go and choose a tool. Out of my library, I'm going to use my 3/8 roughing bull nose end mill. I'm going to select it out of the library, and that's it. I'm going to say OK. And the adapter is going to take a look at everywhere on the part that it can remove those chips efficiently. So you can see it taking those deep cuts and coming back in and taking those successive cuts as it walks through. So I'm able to clear really efficiently using the adaptive. Now if I take a look at this, I'm going to simulate. I'm going to run it to the end. I'm going to show you this transparently as it runs through. I can see some areas where I take a look at the difference between of what was left from the adaptive and what's left on my part. I can see the tool because of the size of the tool. I'm not able to get in those little corners there. So what I want to do is I want to go back and I'm going to make a duplicate of the adaptive to come in with a smaller tool. So I'm going to right-click, copy, right-click, paste, and now I'm going to edit this toolpath and change the tool. So I'm going to change this to a 3/16 bull nose that I have in the machine. Select the 3/16. Now if I go and say OK, it's going to calculate, but as it calculates you'll see that it's looking at the same area where we've already removed those chips. So I don't want it cutting air there. I want it to recognize what we've already done. So I'm going to go right-click even while it's calculating. I'm going to edit. What I want to do is go into geometry. I'm going to change this to rest machining. Rest machining remaining stock, R-E-S-T. So if you remember that, remaining stock, what we want to do is we want to calculate from the previous operation in this case. I'm going to say OK. It'll take a look. It's going to see what was done by the previous operation and then apply the new adaptive to clean up those areas that where stock was left behind, wherever this smaller tool can fit. Now while that's calculating, I want to show you another place where you can get more information. We've done a previous webinar. If you do a search for adaptive clearing deep dive, we walked through some of those aspects about adaptive clearing and how it works in 2D and 3D. And another great resource, if you do a search, look at Pier 9's adaptive clearing, where Al Watmo and the team did some more intensive look inside of our adaptive clearing, where you can get a lot of feedback, or shall I say, you can see a lot more information on how the adaptive clearing works. Also,
that is an intensive look, and you know what we'll do is, I don't know if Al's on the call today, but I've got to burn him a little bit. This is a great look for Al, and what we'll do is, Wayne, when we send out the recording of this, we'll include this video so everyone can see this as well.
Yeah, that'd be great. You can also go through our support, go through our forum and ask questions too if you want to get more information. But this is a great resource to look into to learn more about adaptive clearing. You can always search for tips and tricks and other videos within our YouTube channel to get more information. So as that calculated, we're able to clean up those smaller areas between these little, that little landing right there. We're able to get that smaller tool to clean up that area. So the next thing I want to do is I want to clean up the flats that you see in here. So I'm going to use a horizontal toolpath. I'm going to use the same tool, and we're going to clean up all those places. Now, the horizontal, if you remember, this is one toolpath that finds its own containment. It's going to look for any of those areas that it can be applied to clean up the flat surfaces, the flat faces on your part. Now, I'm not going to change the containment. I'm going to say OK, and you'll see it'll calculate. It also finds all the flats on the top of the part. Now, I don't want it to cut those flats on the top, so what I can do is I can change my containment in my heights. I'm going to tell it that I want the top height not to be at the stock top, but I can lower it down, let's say 1/8 of an inch, and now it's going to go down. You can see the top of the toolpath there. It's going to look for any horizontal faces that are below that level. So it's another way to be able to contain as we were walking through last time. So now it found those flats inside of the area that we're trying to contain it to be able to machine those flat areas. Now what I'd like to do is I'd like to finish up using a contour some of these walls inside of here. So I'm going to go up to my contour toolpath. I'm going to use a ball nose mill. I could use the bull nose, but I'm going to use a ball mill to do this one. I'm going to select. Now I want to clean up those sides of the walls there. So I want to be able to tell it I want to use a slope. So I want to be able to not get the bottom where the bottom of the ball nose would be, but I want to get mainly the walls because the contour works really well when you have vertical walls. So we're going to tell it to stay between 30 and 90 degrees. So 30 off the horizontal, 90, so it'll keep along those walls. So right now we're not going to get too much into the boundaries. I'm going to say OK. It calculates, and you can see it's going to clean up along those walls. So it's doing that. You see on the bottom here, it's not trying to clean up along the bottom of the part. It's staying within that 30, 90 degree area. But I don't want it to come out of the part. So it's leaving that area and it's staying, well, it's going around the part. And I want to keep it inside of those cavities. So what I want to do is I want to add some of that containment that we talked about. So I'm going to go into my machine boundary. Right now it's looking at the silhouette of the part, which is basically the outline of the part itself. And we're saying we want to be able to keep the tool outside of the boundary. If I hover over, you can see some of the options of what it looks like to have the tool inside of that boundary, center on that boundary, or outside. In this case, I'm going to center on the boundary. I want it to be able to go along that boundary, but I'm going to also say I want to come outside a little bit. In other words, I want it to come up to the edge, but I want my tool to roll out a little bit to be able to get a nice finish on the edge there. So I'm going to add 20 thousandths onto there. I'm going to say OK. It's going to recalculate the toolpath. Keep the tool within that boundary where I want the tool, and it's going to come outside just that little bit that I told it where I want it to. So it's another way to apply that containment to be able to remove off the walls. So we have the walls being cleaned, and I want to be able to clean those floors in here. So I'm going to use a parallel toolpath. So I'm going to go into parallel. We'll keep that same ball nose end mill. For my geometry, now I don't want to have it do the 90 degrees. I want it to stay right on the bottom. So I'm going to go into the slope. I'm going to change that. 0 is okay off the horizontal, but I want to go up to 35 degrees. So we're going to overlap by 5 degrees from the contour toolpath. Okay, so right now I'm going to leave it like that. I'm going to say OK, and you'll see it calculate. So now it's cleaning up. I have a pretty wide, pretty aggressive step over there, as I see, but it's also cutting these top of the part as well as those areas where we had the horizontal. So I don't really want to cut over top of those areas, so I have to add a little bit more containment. So if I right-click, let's edit, and now for my geometry, I'm going to tell it that I want to avoid those surfaces. So we can add surfaces where we don't want the toolpath to go to, which would be this one. All those flat areas that we were cutting earlier inside of here with the horizontal. I'm going to say OK. Calculates, and now we only have that area outside of the flats. Again, that looks quite aggressive. I want to be able to make a finer step over into that toolpath, so I'm going to edit. Go into the passes where you'll find your pass direction and your step over. So I want my step over to be about 1/10 of a tool diameter. So I'm going to change this and edit an expression, and I'm going to type in tool underscore diameter multiplied by 0.1. So I'm going to go 1/10, if I could spell it right, of my tool diameter. And it calculates and it gives me 1/10 of the tool diameter. So you can use the expressions to drive your toolpath, and you can also find those expressions if you can also do a search in our Autodesk Knowledge Network, and you can also, what we call as a dump, you can also output that in the post, and we can find that as well if you do a search in our forum. Also, I want to change the pass direction to 45 degrees to make it easier as the transition between those vertical walls there.
Wayne, can you maximize your screen? There's a couple people wanting to see a little bit better. You can maximize the inventor window there.
Sure. All right, so now we have it at 45 degrees, and we can take a look at this. So I'm going to go and simulate what we've got so far. I have my stock turned on. It's showing transparent. I can do this. I can simulate through. I'm going to speed it up as it goes through. Do any adaptives. Coming back for a horizontal there. Looks pretty good, but if I look closely and we're looking at it through transparent, I can see in those areas in the corner there where the tool didn't reach. I have these little radii in the corners. So I'm going to come back and clean them up, but it looks pretty good. Let's do that. So I'm going to do that with a pencil toolpath. 3D milling, pencil. Pencil's another toolpath that finds its own containment. It's going to look at all those internal corners where that tool can fit. Right now I have a 1/4-inch tool that's going to be a little bit too big to fit in those corners. So I'm going to choose my 16th ball. Okay, and I'm going to leave it the way it is now. I'm going to say OK. Calculates and it finds all those areas, but I only have a few passes in there, and I really like to clean them up nicely. And plus, it looks like it missed a lot of those areas where that tool can easily fit. So I'm going to go and edit that, go into my Passes tab, and I want to do a number of step overs. Let's say we do 10 step overs. Looks like we have a nice fine step over there, but I'm going to add some over thickness in here. So I'm going to add 1/8 of an inch, oops, 1/8 of an inch to reach into those bigger areas where that tool can fit. So I'm adding some over thickness. And it calculates. It's able to find those areas, as we're done calculating there, those areas that it missed before to be able to see in those corners to be able to clean them up. All right, so that's applying some of those toolpaths that we learned about, how we can use the horizontal, the pencil, they find their own containment. We can change the containment on the parallel. We use the surfaces to avoid the top and the flats. Again, the horizontal found the flats. Using the contour, we're able to limit it. We're able to change the containment to keep it along those vertical walls. Contour really likes to have more of those vertical walls in the taper. And our parallel, we're able to clean up the floors and change the angle and really make it nice and fine. So adaptive got us clearing out that area, and we're able to finish out that part, run it on the machine. Now, let's say we have a very similar part to this that I'd like to run those same toolpaths. I often do a lot of these type of parts. So what we can do is I'm going to highlight, hold Shift, select those toolpaths, right-click, and I'm going to store them as a template. I'm going to put them on my desktop for now. I'm going to call it my mold part template. So I like the way that these toolpaths are set up. They run really nicely. I like the way that they find the geometry that I need. And if I had a similar part like this one, and I want to apply those same toolpaths to a part like this, I already have them all set up. I have my tools selected. All I have to do is right-click, create from template. Now I already did my setup in this part, so you just simply set it up the way you have it in the machine. Right-click, create from template, and there is, I can select each one, and I can select all templates. Now in some places I had to select specific geometry, but that's okay. I'm going to go and take a look where I can add that. I just simply right-click, generate the toolpath, or Control-G. and it found a lot of those areas, well, this is pending, where that tool can fit efficiently. The same tools it brought with it, and it's finding that geometry where that tool can go best or most efficiently to remove those chips. We'll wait for the finishing one to clean up, or the secondary, but there it has the contour. And there's my roughing with the parallel, or my finishing with the parallel, and I can simply select those areas that I don't want the tool to go to. So again, I go down to my avoid touch surfaces. I want to avoid these areas, select those pretty quickly, and now I'm able to get all those toolpaths working as I expect, like the last part. So you can quickly set up your toolpaths for similar parts and save them as a template, bring them right in and be able to work with them on new parts. Okay, so there's one more thing I'd like to show. And if I bring this up real quick, there's other areas where you could find other information on containment. A great place to look would be Rob Lockwood's video. He walks through some great interface on how to contain and how it works, the containment works. This is a great video if you do a search for Rob Lockwood's video. He and Tim Paul did a webinar. If you find that webinar, a lot of good information there as well. And I'm not going to get too much into some of these other strategies at this point. We're going to have future webinars for those. But you can find, again, searching our YouTube channel, a good overview on other toolpaths like scallop or radial, spiral, morph spiral, project, and even our morph toolpath. One of them I'd like to look at it in a little bit more depth because it was pretty neat. One kind of fun thing I was working on was a project like this where we have a contour and ramp. So our ramp toolpath does a really neat way of keeping that tool on the material as much as possible. So you're removing, like this is the contour where it does a cut, moves down, does a cut, and it moves in the Z for each cut. The ramp stays constant to the material. It stays constant on the side of the part. Now I've worked on a project here where I wanted to be able to get inside of a shape like this, a little ball shape inside of the part. I can get a closer look. I'm going to go over to my, let me go into my model here real quick, expand this down, there we go. And then I'm going to do a view where we can see a half section view of that. So getting into something like this, being able to clear that material out of there was a neat project to go through. And I have a slot mill with radial corners on the top and the bottom that can get in here really nicely. So I wanted to do is I wanted to set it up, drill out this area in the center there. So as I go back to my model, I'm just going to show this sketch real quick. Go back into CAM. You can also hit Alt-A and Alt-S and move within these these menus right here. So if I'm going to do a drill toolpath, I'm going to select the drill, my 3/4 inch drill there, and I want to select the point. So I'm going to go to geometry, select this by points. I'll select that little point right there. So that's going to be the bottom of my drill toolpath so I can drill this out. It's like I don't have a shaft of a hole to select, so I'm going to use it by points. My height, I want to make sure that I'm entering at the stock top, so I'm not going to cut into my part. So we're going to do a quick pre-drill there, and I'd like to machine this area out here. So a neat trick that I found was being able to use a ramp toolpath using a slot mill with radii on the corner there. This is 50,000 radii on the corner there. So I select the slot mill, and I want to try to get into this little path right here. Now, I don't have to select any specific geometry, but one thing we want to do is I want to make sure that for the bottom, it doesn't try to calculate in this area right here or the toolpath will fail. So I want to select this edge right here to stop the toolpath as it reaches that bottom so I don't have to get into that drill area either, and say OK. And it'll calculate. It'll give us a nice ramp toolpath into the part. And you can change how fine you want it to go as it gets into that part, but it does stay along that side. Now you can also use a ball mill to be able to get that same toolpath. Yeah, come on. or should I say not a ball mill, a lollipop mill. Oh, it went on the outside. Here's what I did. So it found the outside of the part as being the area, but it did do that nice little shape on the inside. So I want to limit that. So that's one thing I forgot was going into here. It's going to look at all the places where the tool can go efficiently. So I want to change this to say I only want the tool to stay inside the boundary. I don't want it to go outside of that boundary. So it'll recalculate and stay inside of the silhouette. In this case, I think what I did was I also chose a selection, and I chose that edge and then to stay inside of that edge, just so I don't get on the top corner there where it's inside the boundary. So it's just fine-tuning what your boundary is where you want to keep the tool. Well, that's interesting. Very interesting. It didn't chop it up like that before, but there's probably something I did with the boundary.
You picked an edge that's smaller diameter than the large diameter of your cut, so maybe probably the farther edge, farther out.
Gotcha.
But it's good to show. It's good to show what's happening here.
It is. It is.
So my guess is maybe you picked the outside of that at a radius.
So inside, I probably did. Let's go in here. This edge right here. But we'll see what we get. And that's part of the fun. That's really the neat thing about what we do, is getting in here and we have a challenge. We have a shape like this, and we want to know how can we cut something like that? What can we do with our machines and the tools we have to be able to get things like this done? And that's part of the fun of it, is learning, the limitations of your tool, using tools, using HSM to learn the toolpaths and things that you're able to do and stretch what you wouldn't normally do with those toolpaths. And it works. I mean, it does what we need to do. So I just wanted to point out one of those places where ramp, you wouldn't typically think of using a ramp to get such an undercut like that using a slot mill, but it works well. And you can fine-tune, really set your step downs really fine, or your passes. So I just wanted to share that. So that's using the ramp mill. But that's pretty much it for today. I wanted to walk through how to apply some of those toolpaths and then give you a little bit of a tip and trick on working with the 3D toolpaths. So we're going to have a lot more in the near future. We have a lot of great webinars coming up to keep an eye on. Next week we're going to be talking about our year in HSM, all the awesome things that we've accomplished and things that our team has developed and brought to us within all of our HSM interfaces, all of the events, the things that we've done over the summer, our webinars, our tips and tricks, and walk through a lot of those great things with you. And in the next year, we have a lot of great webinars coming up. Even our CEO, Carl Bass, is going to walk through some of his projects with us in January. So keep tuned with us. It's going to be awesome. We have a lot of other great speakers and a lot of information coming up in the near future.
I think you underhyped that. For those that don't know, Carl's got his own personal machine shop where when he's not running the company, he's enjoying making parts. So Wayne was able to get him to commit to coming on and sharing some of his CAM experience with the user. So that's definitely a don't miss opportunity.
Yeah, and that's one of the things that, makes the HSM platform so unique, is that, the leader of this multinational, multi-billion-dollar organization that has hundreds of different products in all different verticals and industries has a personal interest in making things. And because of that personal interest, we're seeing a significant investment in the HSM platform. So that'll be an event not to miss, and I'm sure we'll get the word out in a big way when that event happens. So, everybody, thank you so much for joining us today. Wayne, if you could open up a browser real quick, just really briefly. I know a lot of people out there have friends and family that are students and educators that might be interested in possibly starting their own business, or possibly, just getting exposure to some of this incredible technology. And for those of us that know students and educators, all you have to do is Google the Autodesk Education. It's It's free software for all, and literally you can look at the list of products here. It's not just HSM, everybody. It is just a phenomenal offering from Autodesk, so please encourage those that are interested in any sort of STEM program or just learning more about technology to leverage this, because while you're a student, while you're an educator, you can get access to this technology for free. It's truly a phenomenal gift that Autodesk is giving to the community and the world. Another resource, Wayne, that maybe we should touch upon is our CAM forums and the Knowledge Network.
Yep, so one of the, that we had mentioned before, this is a great forum to go to, very active in our community. A lot of our developers and our power users are in here every day answering questions. It's a great resource to go if you have questions and are looking for particular information on a toolpath. Our posts, we have a post library, or shall I say library, we have a post forum to go in and ask about post, learn about your post processors. We do have a good post library that you can look for and work with online. I think I have a link to our library. There's our knowledge network. If not, you can also go to, just look for Autodesk. I would go to Autodesk or cam.autodesk.com and then look for our post library. Or even just go to our main site, cam.autodesk.com, and you can find lots of links up here where you can find that information as well. So you can link to our events, our weekly webinars, our tips and tricks each week. You can link to our learning page where we have our CNC handbook. It's really helpful when you're getting started with working with CNC, as well as our Toolpaths. You can get step-by-step walkthrough on how to get started with our interfaces. And so looking for, I had mentioned our post library, jumping over to our post library. You can also look for your machine in our list. This list, this website gets updated daily. And you can see where there's a lot of updates happening. So our posts get updated. We work with Haas. We work with a lot of the machine manufacturers to be able to get the latest post updates to you. So if you're working with HSM and you don't find your post, you can always go here, the cam.autodesk.com post. They'll try to find your post in here. Again, you can always go back to our forum. We have a great post forum to help you get started with learning more about your post and searching for a particular post that you have.
Great. Thank you so much, Wayne. And Al, thank you so much for joining us, and everybody else that comes together to help put these together. I would like to mention that on Wednesdays, for those of you that are new to the platform, we do host another quick start webinar. So if you're struggling and you just need some help getting off the ground, that's a great place to go as well. And as always, feel free to reach out to any of us on the team. We're very friendly. We love this stuff. We live it. We breathe it. We want to see you be successful with this technology. So please, don't be a stranger. Hang out, same place, same time. And oh yeah, here we go. Wayne, this is really your baby, the Wednesday ones.
Yeah, if you are getting started, you're brand new, just download it. You want to get to know a lot of the Toolpaths, how to work with them, the basic get started. You can join us every Wednesday. We alternate turning. So if you're working with your turning machine and trying to get some good Toolpaths on your lathe, we have a list of which week we're doing them, and then we do 2D milling, 2-axis milling, or shall I say 3-axis milling, but 2D. We get you started with our interface. So it's a great webinar. Join us every Wednesday.
Yeah, awesome. Well, with that, everybody, thank you so much for joining us today. My name is Jordan Roberts. If you have any questions, feel free to reach out to Wayne, myself, Al, anybody on the team. We're here to help. Use the forum. It's a great resource, and we all look at that as well. And it's our own employees, it's our own users. It's a very incredibly active forum. It's truly something special. So next week, we've got the year in review, where if you've ever been wondering about, hey, what's going on? What's happened with the HSM community? What's going on with HSM Works? What's going on with Inventor HSM? What's this cloud business about? What's Fusion? This is a great place to come, tune in, and learn about everything that's happened in the last year is kind of like a year-end review. And as always, if you guys have any suggestions that you want to see inside the software, please use our idea station and upvote those ideas. And Wayne, maybe we can just touch on that real quick.
And while you're doing that, Wayne, one more thing that came up in the comments here that we should hit on. There's some people that have asked some CAD questions, maybe some Fusion users here learning some Fusion CAM tricks. There's also a very specific Fusion community, so the greater Fusion product, CAD, CAM, the whole bit. So the Idea Station and the Fusion community might be a good thing to show quickly.
Absolutely, absolutely.
So here's our Idea Station where we start. You can go in and take a look. If you're looking at Fusion, you can go into the Fusion Idea Station, and as soon as it pops up here, it's a great place to go to get your ideas. If there's a place in the software that you're trying to look for an easier way or something that you think would be good to have in the software, add it here. Add it in and make a post inside of our Idea Station. Our developers and our team looks at these, and other people who are in the community look as well. And if there's a great idea there, you can see that people will vote with you. And the more votes you get, the higher it gets on the list of the things that will get completed or implemented in the software. So it's a great place to go.
It's pretty phenomenal that a software company the size of Autodesk is able to take direct customer feedback and port that over to the development team. And incredible guys like Al and the rest of the team that works with him are able to take your real-world feedback and apply it to product to really provide even more value. So I'm not sure if I know of very many other software companies the size of Autodesk that are able to operate with that sort of agility, but that's absolutely a huge, huge value set to everybody that's involved with this technology. So please leverage the Idea Station. It's a great way to see your ideas, make it into the product. Awesome. So yeah, next week we've got the year in review, where we're going to cover absolutely everything that might be hard to get all that data from all these different places because we've just got so much going on. So please join us for that. Same place, same time. And I'd like to encourage everybody that's on the webinar today to invite a friend. Tell a friend about the HSM platform. Get out into your community. If this has helped your business out at all and you've got somebody who's running a machine shop, has a CNC machine, or just has interest in this stuff, let them know. We've got all sorts of resources. It is hands down the easiest platform to use and get started on, and just a revolution in the machining space. So thank you so much, everyone. We'll see you next week, same place, same time. Wayne, Al, thank you so much. Everybody else on the team in the background, our customers, thank you so much for joining us week over week. We'll see you next week, where we're going to be covering the year in review. Have a great weekend.
Thanks, everybody.